Welcome to Next Gen Manufacturing. Today, we're going to dive into the digital revolution in engineering, the story of how we went from massive stacks of paper blueprints to the intelligent 3D models that are now the foundation for the factories of tomorrow. So let's start with a really big question. How do you pull off a project worth $1 billion, with all its mind-boggling complexity, without making a tiny mistake that ends up costing you millions? This is the central challenge of industrial engineering. It's not just about building it, it's about building it right the first time. And this quote right here is basically the fundamental law of the universe for any large-scale project. Think about it. An error you find on a drawing, that's just a few clicks with a mouse to fix. But that exact same error found after the concrete has been poured or the steel has been welded into place, well, that's a catastrophic, budget-shattering nightmare. This one simple idea is what drove the entire industry to find a better way. To really appreciate just how revolutionary modern digital tools are, we've got to take a step back and look at how unbelievably difficult it was to manage these projects in the analog age. You see, a big industrial project is kind of like trying to conduct a massive symphony. You've got all these different specialists, the civil engineers doing the structures, the process designers, the piping teams, the electrical folks. The list goes on. Each one is a master of their craft, but they all have to play in perfect harmony to make it work. The problem was, in the analog world, that harmony was almost impossible to achieve. Why? Because every single team was working from their own separate set of paper blueprints. The structural guys had their drawings, the piping team had theirs, and the only way to check if a pipe was going to run through a beam was to literally hold the drawings up to a light table and hope you caught the mistake. And this really shows you the heart of the chaos. It was a massive circular dependency problem. The piping team needed the building layouts from the civil team before they could route their pipes. But the civil team needed to know where the heavy equipment was going to be so they could design the concrete foundations. It was this constant, slow, and incredibly error-prone loop of just shuffling paper back and forth. So, of course, computers enter the picture and everybody thinks, great, problem solved. But, well, it wasn't quite that simple. Their first impact was actually pretty isolated. What happened was that computerization created these little islands of efficiency. Sure, it was faster to type up specifications in a word processor or run calculations on a spreadsheet, but none of these tools were talking to each other. They didn't solve that core coordination problem at all. They just made the individual silos a little more efficient. Okay, the next really big leap forward came when we moved the actual drawing board from the physical world onto the computer screen. This was the dawn of computer-aided design, or CAD. Now, CAD systems, or CAO, as they were known in French, where a lot of this pioneering work was happening, totally changed the game for drafting. All of a sudden, creating a drawing and, more importantly, changing it became exponentially faster and easier. But this comparison here shows you both the huge step forward and the big problem that was still left. Yeah, 2D CAD made things faster, and you can make perfect copies. But fundamentally, it was still just electronic paper. The piping drawing was one file, the structural drawing was another. The computer had no intelligence. It couldn't tell you that a line representing a pipe was about to intersect a line representing a steel beam. The real revolution, the true paradigm shift, happened when we stopped just drawing pictures of the factory and started building a single, shared 3D model of the factory itself. This changed everything. This gave rise to the concept of the maquette virtuelle, or the virtual model. This wasn't just a collection of drawings. It was a single, data-rich 3D database that everyone worked on together. It became the one and only source of truth for the entire project. The entire way of working was completely flipped on its head. Instead of every discipline making their own separate 2D plans and then just hoping they'd all fit together in the end, everybody started working inside the very same digital space. The process would start with the civil engineers, who would model the bones of the factory, the concrete foundations, the steel framework, all in 3D. Then, the next teams would come in and place every single piece of major equipment, we're talking pumps, tanks, reactors, directly into that virtual structure, using the exact precise dimensions. And then came the really complex part. The piping and electrical teams would route their incredibly dense networks right through the model, connecting everything up. And the beautiful thing was, because everyone was working in the same model, if a pipe was on a collision course with a beam, the system would scream at you instantly. This unlocked a whole suite of powerful new tools they could only have dreamed of before. Automated collision detection was the big one, of course, but you also got real-time coordination, automated checks. You could even automatically generate all the detailed manufacturing drawings right from the model. It was a total game changer. And the results? Well, you can see it right here on this chart. The impact on those costly on-site errors was just staggering. By solving literally thousands of clashes in the digital world before a single piece of steel was ordered, this 3D virtual model approach slashed rework and saved unimaginable amounts of time and money. But the story doesn't even end there. This digital foundation didn't just change how we build factories, it fundamentally changed what the engineering deliverable even is. Think about it. In the past, the final product from the engineering firm was a truckload of paper. Then it became this incredibly detailed 3D model for construction. But now, we're looking at that model as something even bigger, a living, breathing, digital asset. Yep, that's right. This virtual factory doesn't just get archived on a server once construction is done. It becomes the plant's digital twin, a perfect virtual replica that's kept alive and updated. The operations team uses it for training. The maintenance team uses it to plan repairs, and engineers use it to simulate upgrades. It's the factory's blueprint that lives and evolves for decades. So we've built the digital blueprint. We have this rich, data-filled foundation for the modern factory. And that perfectly sets the stage for the next great leap, layering on artificial intelligence and machine learning. The modern factory was born digital. The really exciting question is what happens when it starts to think? Thanks for watching.